Anyway, hi there. I'm going to very briefly sort of introduce the sort of general theme of this discussion session, which is sort of using program synthesis to make game development more approachable as an expressive medium to a wider range of potential users, including people who aren't necessarily like super code experienced, or who don't feel sort of like super confident writing programs on their own yet. So game design is an expressive medium, right? It's got all these different sort of like affordances that enable it to uniquely model systems. You can use it to talk about things like, systems of oppression, political issues, personal issues, things that you've experienced. And you can do this all through this sort of very high fidelity combination of different expressive forms, which include visuals, which include sound, which include behavior in particular. And behavior is a thing that we usually use code to express. You can see this being sort of like a pattern in things like news games. So games like September 12th or the Uber game, both of which sort of try to comment on real world events or political systems through the use of procedural rhetoric, or basically code that expresses the way that different things in the real world relate to one another, whether that's in a mathematical way or through a behavioral sort of like, you can see little characters in the world walking around doing things. And when you take a certain kind of action that an agent might take in that world, for instance, if you're sort of like trying to prevent terrorism in the Middle East in the September 12th scenario, you might sort of, use a drone to attack these groupings of civilians, right? And that can lead to sort of negative consequences spiraling out of that. Or again, in protest games like the McDonald's video game or Unmanned, you can see sort of like attempting to model and comment on real world issues through procedural rhetoric and through sort of the game mechanics, where the behaviors that you can express as a player then sort of feed into these systems in various ways, and you get to see the responses that sort of emerge. And in particular, I'm really fascinated by these personal games that comment on maybe queer issues or issues of mental health, and that try to express either through things like movement through physical space, or models of sort of choices that you can make in interactive narrative scenarios, the way that it feels to experience being transgender or being depressed and things like this. And these approachable game creation tools have tried to facilitate the creation of games like these. So on the left, you see Flatpak here, which is sort of it's a flat game creator, where flat games are basically interactive collages that are full of a bunch of 2D sprites, often either hand-drawn or cut out from photographs. And you can sort of maneuver through a world that contains a lot of them. Is there a question? Oh yeah, so Chris mentions that it's perhaps worth clarifying that September 12th is satirical. It does not support bombing the Middle East. That's yeah. Good point. Um, and so yeah, approachable game creation tools like Flatpak, like Bitsy, which sort of allows you to create these little 2D story worlds where you can walk around and there's all these pixel sprites that have sort of dialogue you can sort of engage with, et cetera, et cetera. And these tools allow you to express ideas through behavior in a way that games are very powerful in that sense. But they're limited in the operational logics that they can express. In particular, they don't have sort of the full capability of open-ended code to express systems and their relations to one another beyond very simple, movements through 2D spaces, or sometimes collision logics and things like Bitsy. And so the combination of these different operational logics into more complicated procedural rhetoric or complicated procedural models of phenomena is one of the things that's critical to games as an expressive medium, sort of being like fully able to express all the ideas that they can express, basically. And there's a bunch of barriers to entry around game development. One of them being that open-ended programming is difficult, right? So if you don't have a whole lot of, finicky programming knowledge, it can be very hard to go in with an idea of what your game design is supposed to be, and then figure out how to turn that into a program that actually implements that game design. And sort of going from these high-level design ideas to these lower-level expressions in code of what you're intending to say can be a very difficult process, even for experienced programmers, let alone for people who don't have a lot of code confidence or code knowledge necessarily coming in. And these more approachable tools have definitely expanded participation in these medium, right? So like Twine has sort of brought in a lot of queer creators, for instance, and Bitsy and Flatpak have done like significant things to make those particular kinds of games way easier to make for people who have not necessarily had game making sort of abilities before. But because these tools impose restrictions on the operational logics that users can work with, they're still limited in their ability to express the full range of behaviors that we want to express in games. And so the problem becomes how to assist these inexpert programmers in expressing a wider range of design ideas through code, right? And the one potential solution to this is the introduction of program synthesis to this development process, in which we generate programs that satisfy user intent, whether that's provided as examples of the behaviors you want to create, as sort of high-level constraints that you've written down in an easier to articulate language, some combination of those. The broad idea of program synthesis is basically to go from high-level intent to low-level code via sort of a computational process. And I sort of propose in this sort of short paper I've written these 3 high-level categories for research that might be sort of like taking us in this direction toward the use of program synthesis to support game design as becoming a more approachable form of expression, basically. And here there's expressive synthesis, which is sort of generating code that expresses feelings or ideas. Reflective synthesis, which is using the program synthesis process to help users formulate and refine their expressive intent or what they're trying to get across with a game, basically. And educational synthesis, or using synthesis to sort of guide and support learning, as was actually mentioned in the previous talk, as like sort of exposing users to code constructs or code patterns that they might not have been familiar with before, but in an environment where they don't have to know completely how it works at first, and they can sort of, through repeated exposure, build up sort of a sensitivity to the meaning of those code constructs, basically. And a couple of key examples of these systems that exist already. In expressive synthesis, we have things like Germinate that sort of take a high-level design intent that's been expressed on the left in terms of how these different entities and resources relate to one another. In this case, we're making a game about depression, so we have like friends and a depression resource and a confidence resource that can sort of go up and down over time. And it sort of generates games that match this intent in various ways. And you can sort of move through the space of generated games to pull in parts of the generated games that you think match or sort of satisfy this intent, or exclude ones that don't, basically. Or things like, the generation of boss behavior programs. So in program synthesis as a generative method, we see sort of the PCG community adopting program synthesis to basically create these NPC behaviors for these boss enemies that you fight in some kinds of video games, right? And you can see that there's sort of a state declaration where there's a bunch of different variables that define like the boss's health and the boss's speed and projectiles and things like that. And then it sort of creates these almost behavior tree-like expressions of how these things all relate to one another, and you can sort of iterate through this space to find the kinds of boss behaviors that they're looking for, basically, or even evolving behavior trees directly. So there's some recent work that's been done on sort of using these sort of unreal formalisms of behavior trees to evolve NPC behaviors for things like again, characters in video games, basically. And so that's sort of expressive synthesis of like trying to use programs to express ideas and generate programs that can express ideas in the ways that you want them to. And reflective synthesis is sort of trying to help users formulate and refine their expressive intent through the synthesis process. So that can include things like synthesifter, which are trying to basically, in this case, you're generating story sifting patterns, right? So you sort of select example sequences of events that have happened in games, and it sort of generates a pattern that can match those sequences. And you can sort of add more positive examples, more negative examples, and even directly edit this code that's been produced up here as you sort of get a better and better idea through this example-based specification process of what exactly it is that you're trying to match, or what sort of behavior you're trying to articulate to the computer, basically. Or things like in the program synthesis community, there's been recent work on sort of human-centered program synthesis and trying to do things like visualize the space of all possible programs so that you can basically sort of guide the synthesizer toward the parts of the program space that are closer to what you want, even if it hasn't quite reached the ideal implementation of the behavior that you're trying to specify yet. So like there's a whole bunch of examples here, and you can sort of see that as the user is sort of making annotations on this tree of different programs that it could generate, you can see how many of those examples are satisfied over the course of the search process and sort of see if you're making forward progress. And sort of engage in this interactive dialogue with the synthesizer of trying to articulate like what it is that you mean exactly. And then finally, there's this idea of educational synthesis, of using synthesis to sort of guide and support learning, whether by generating programs that introduce new constructs to the user, maybe teach them about things they wouldn't have sort of known otherwise, and building up maybe a knowledge model of what the user understands about programming and how sort of, code can be linked to design in the game design context. And so these are sort of the high level categories that I've proposed in this paper. A few sort of ideas for future work that might come out of this are things like, a synthesis powered game design journaling tool that asks users to explicitly draw connections between the different parts of their expressive intent. Like sort of, I want this enemy to feel sort of aggressive and I want this one to feel cowardly. And the specific bits of code that implement that behavior to sort of refine their understanding in some way of how the code links to the intent and vice versa, basically. Or things like encoding design constraints, like this number only goes down in the type system, so that you can use sort of type-directed synthesis techniques to sort of further explore this search space of possible programs more efficiently, basically. Or things like modeling user knowledge of the game engine features that they're working with. So in Unity, there's a whole bunch of different APIs you're using, and maybe you want to start with a very small subset of these, the ones that the user sort of understands by default, or that you're assuming they understand, and then gradually introduce new ones over time as their code sort of moves in directions where that sort of thing would be useful, or maybe sort of like you can sort of match the code that they're writing to, this would be simpler if you had this sort of feature being used here. So I'm going to show you how that works now. And sort of the point of this discussion is to draw out other ideas for future work, and sort of how these ideas of, game design support on the one side and program synthesis on the other side can sort of work together to make game design more approachable. So I think those are all the slides that I've got, and I will go ahead and I think segue into discussion.